Hi everyone. So in this video we are going to start a standing wave pattern. So a very important topic and it is asked in the examination 100%. Like if they are framing a question from transmission line, then certainly they will ask question from here. Now there would be some guys, because this topic is critical as well and this topic is important as well. So a lot of guys would be coming on this channel just to understand this particular topic. So if you are someone who is coming just for this particular topic, so first you need to watch this video. If you are someone who is following this playlist, then it is fine, you would have certainly watched this video. But now if you are someone who is only here to understand the standing wave pattern, so first watch this video. I have spent here 2 hours and 30 minutes. Okay, so 2 hours and 30 minutes has been spent here. I told you when did you get a standing wave pattern, what is the meaning of standing wave pattern, what is the meaning of a standing wave, what is the meaning of a traveling wave, and when a traveling wave is there and when a reflected wave is there, both combined, both superimposing makes a standing wave. So this concept has been already delivered here. How to solve problems related to standing wave, that also has been discussed here. So first you need to spend 2 hours and 30 minutes here, then only you can come. Okay, so first spend this much of time, then come to this video. In this video, then this video will be a kickbook for you. In this video as well, first hour will be very critical. Okay, in first hour I am explaining how do you draw a standing wave, what is the meaning of a standing wave, and how do you get a standing wave pattern. After that we are just solving the problem, we are just building up the problem solving skills. So this video is very important, then only you will be able to understand this particular video. Okay, so let's revise it in a brief, that how do we get standing wave pattern. There will be an incident wave, then there will be a reflected wave, and both superimposed will make a standing wave pattern, right? So this is what we studied. So this we need to study in transmission line now, because in transmission line what happens, in transmission line as well there is a forward traveling wave, there is a reflected wave, and both combined would make a standing wave pattern, because this was your transmission line, this was your source end, and other was your load end. So some wave would be coming here, that would be reflected back by the load. So two waves will be there, and combining both of them they will make the standing wave pattern. So this we need to study. So first let's discuss about reflection coefficient. So this we have already seen. What was the formula of voltage reflection coefficient? That was ZL minus Z0 upon ZL plus Z0 e to the power minus 2 gamma y, in terms of y if we are writing. Okay, and what do you mean by reflection? Some incident wave is coming, that is V0 plus, and then there will be reflected wave, that would be V0 minus, right? So reflection coefficient is given by this. Now voltage reflection coefficient for a lossless line, what it would be? For a lossless line, what will be the value of gamma? Gamma will be equals to J beta for lossless line. So just replace J beta here, ZL minus Z, and what is Y here? Y equals to 0 and Y equals to L. Y is that distance from load. All these things we have seen in a very good manner, right? ZL minus Z0 upon ZL plus Z0 e to the power minus 2 J beta, and in terms of y only we are writing. Okay, so this is the formula. Reflection coefficient for a lossless line at any random point on transmission line, that is ZL minus Z0 upon ZL plus Z0 e to the power minus 2 J beta y, because in place of gamma we have replaced J beta. Now voltage reflection coefficient at load. So if I am asking at load, so I will put y equals to 0. So what I will get? ZL minus Z0 upon ZL plus Z0. How I can write my Vy equation? So what was my Vy equation? V0 plus e to the power. Now I am writing for lossless line. For lossless line. Okay. So if you are writing for lossless line, then gamma will be replaced with J beta. So what was the equation? V0 plus, in which direction it is traveling? Negative y. So V0 plus gamma y. So in place of gamma, what you need to replace? J beta. So V0 plus e to the power J beta y plus V0 minus e to the power minus J beta y. Okay. What V0 minus can be replaced with? V0 minus can be replaced with gamma VL V0 plus. So V0 plus e to the power J beta y plus gamma VL V0 minus, gamma VL V0 plus e to the power minus J beta y. So this is how your equation can be written. Now this is, from here you will get the standing wave pattern, and you just need to find when do you get voltage maxima and when do you get voltage minima, current maxima, current minima, right? Because if you have already seen this video, then you would be having the idea what I am talking about. Let's solve a question regarding reflection coefficient. So this was asked in gate examination only. So reflection coefficient measured on the line at a point A. So this is a transmission line. At a random point A, your reflection coefficient is given. AA dash, you can say AA dash. At this AA dash, your reflection coefficient is given, which is 0. Reflection coefficient at some distance y is given, which is 0.2 and angle 30 degree. Now what they are asking, what its value at a distance lambda by 12 from the above point towards the sending end. Towards the sending end, this is known as sending end, right? Because this was your source. So this is known as sending end, this is receiving end, or you can say load end. So this is the sending end. So lambda by 12 distance from the above point towards the sending end. So that means you are going here. This distance, this much distance. This distance is lambda by 12. So towards you are going here. Are you getting this point? This point I am calling as BB dash. So you need to find your reflection coefficient, voltage reflection coefficient they are talking about, or whatever whichever reflection coefficient they are talking about. You need to find that reflection coefficient at y plus lambda by 12 distance. Why is that so? Because we take distance from here, from load end. So this point is, if this point was at y distance, then this point is at y plus lambda by 12 distance. What will be the formula? ZL minus Z naught upon ZL plus Z naught e to the power, and this is a lossless transmission line. So minus 2j beta y plus lambda by 12, right? Can I break it down in this manner? ZL minus Z naught upon ZL plus Z naught e to the power minus 2j beta y e to the power minus 2j beta lambda by 12, right? Can you let me know the value of this much quantity? Is this given in your question? Yes. How it is given? Is this given in your question or not? It is given because this is the reflection coefficient at point y. So this is given in your question, which is 0.2 and angle 30 degree. I can write it down in this manner. And what this would be? Beta lambda will be 2 pi, 4 pi. So it would be pi by 3. So you can solve it, right? Beta into lambda is 2 pi, because beta is equals to 2 pi by lambda. So beta into lambda is 2 pi, 2 pi into 2, that would be 4 pi, 4 pi by 12 will be pi by 3, pi by 3 means 60 degree. So this is J 60 degree. So what you are getting answer? What is your final answer? 0.2, J 30 and J minus 60. So that would be minus 30. Okay. So this you are finding at, let's call this point as okay, y plus lambda by 12 only. So this point I am calling as y plus lambda by 12 only. So this is my reflection coefficient at y plus lambda by 12. What is the answer you are getting? 0.2 is the magnitude and angle is minus 30 degree. So this was a simple question only. If you know this formula, then this is a simple question that at a distance y from the load, the formula is ZL minus Z naught e to the power minus 2 gamma y. So you are going towards sending end. From load to sending end you are going. Load end to source end you are going. So here we were covering lambda by 12 distance more. So this part would come more than this is the answer. Is that okay to you? Okay. Now let's start the standing wave pattern. So we are not going to see the concept because we already know the concept. Now we will just solve the problem. So take lossless transmission line and you need to draw standing wave pattern for current as well and for voltage as well. So how we will draw it? So can I write down the voltage equation? Yes. What is the voltage equation for a lossless transmission line? V naught plus e to the power minus, not minus, sorry, V naught plus e to the power j beta y, where y I am taking from load, y is the distance from load, plus V naught minus e to the power minus j beta y. But you should have the habit of writing down this step directly. You will not write V naught minus. What you will write? Gamma L V naught plus e to the power minus j beta y. Why is that so? Because V naught minus can be written as gamma L V naught plus. And what is your gamma L now? ZL minus Z naught upon ZL plus Z naught. So 100 minus 50 upon 100 plus 50. This is a resistive load. So for different condition, we will find out the standing wave pattern and then we will make a conclusion. So this is coming out to be 1 by 3. So what you are getting here? V naught plus e to the power j beta y, V naught plus by 3 e to the power minus j beta y. then what we used to do? We used to take V naught plus e to the power something outward. So what I am gonna do? V naught plus e to the power j beta y. This I am taking outward. Here 1 plus 1 by 3 e to the power minus 2 j beta y. This is what I am getting. Now using this expression, I would find my maxima and minima and maximum and minimum value. So using this expression, you can certainly find. How you can find? When it will have maxima, when it will have minima. With respect to cos, we will be thinking. So all these things we have already done. So this is your Vy. If you need to write down the magnitude of Vy, then what it would be? Magnitude of Vy. Actually, here I should have written Vsy, not Vy. Why Vsy? Why I am writing Vsy? Because this is a phasor form, no? Here I should have written Vsy, or you can write Vy as well, because we are seeing this equation in phasor form. This is not a time harmonic vector. Time harmonic, it's not vector field. It is not time harmonic field. Why it is not time harmonic field? Because we did not introduce e to the power j omega t. If we need to see the time harmonic field, then we can introduce e to the power j omega t in the same manner that we have done in our EM wave. So that we are not introducing, we are directly analyzing it with respect to phasors only. And in the standing wave pattern, we also studied that standing wave pattern is always analyzed with respect to phasor, right? Now we are just writing down the magnitude of it. So here this is a phasor term only, this is a phase term. So this complete will give a magnitude of V naught plus, and then here magnitude will be 1 plus 1 by 3 a to the power minus 2j beta y. Okay, let's keep it somewhere here. Now you need to tell maxima and minima. Maxima here and minima here. So what will be your maxima? 2 beta y. So for maxima, what is the condition? Here this should be 0 or 2 pi or 4 pi. So what I can write? 2n pi. 2 beta y is equals to 2n pi. So from here what you will get? Or 2 beta y, or I should have written minus 2 beta y. Basically, whatever that is there in e to the power j theta. So this theta should be equals to 2n pi if there is a plus sign. If there is a plus sign, theta should be equals to 2n pi for the maximum value, right? So minus 2 beta y should be equals to 2n pi. I am telling you first you need to watch the very first video. This video you need to watch, then only you will be able to understand what we are talking about. Otherwise you will not be able to understand. Okay. So minus 2 beta y is equals to 2n pi. So 2 beta can be replaced as 4 pi by lambda is equals to minus 2n pi. So from here y is coming out to be minus n lambda by 2. So here n value you will put positive or negative. If I put n equals to 0, okay, this is applicable. Y will be equals to 0 only. This I am finding y maxima location. So if I put n equals to 0, it is fine. But if I put n equals to 1, then minus lambda by 2 you are getting. So that is not correct. So n equals to minus 1 you will put. So here negative values we will put. Okay, just a very simple thing. This you don't need to mug up that in EM wave we are putting positive, in transmission line we are putting negative. No, you just get to know that here if I put 1, then that doesn't work. So I need to put minus 1. So minus 1, minus 2. So these values you need to put. So n is equals to 0. I can put minus 1, minus 2 in that manner if I put. So what will be the location of my maxima? 0. If I put minus 1, that would be lambda by 2. If I put 2, then lambda. In that manner I am getting my maxima. And for minima, minus 2 beta y should be equals to what? First location would be pi, because that cos pi is minus 1. So first location would be pi, and then 2n pi difference. So what I will write? 2n plus 1 into pi. Pi, 3 pi, 5 pi, 7 pi. There you will get minima. So till now you must have got a good enough practice of this particular concept, right? Minus sign is also there. So y is 2n plus 1 lambda by 4. So first n equals to 0 I can put. Next what I will put? N equals to 1 or minus 1. If I put n equals to 1, then what I am getting? Minus 3 lambda by 4. So that is not applicable. So what I need to, if I put n equals to 1 here, so minus 3 lambda by 4 I am getting. But if I put n equals to minus 1, then what I will get? N equals to 0 I am putting, n equals to minus 1 if I put, then I will get minus 2 plus 1 into lambda by 4 minus lambda by 4 I will get. Plus lambda by 4 I will get actually. So if I put n equals to 0, if I put n equals to 0 here, what I am getting? Minus lambda by 4. So this is also not applicable. n equals to 0 if I am putting minus lambda by 4, because my value should be positive. So I am getting minus lambda by 4, so that is also not correct. If I put n equals to minus 1, then what I am getting plus lambda by 4. So this is the first location of your minima, right? So we need to start from n equals to minus 1. This I told you that you don't need to remember whether you need to put whether you need to start from 0 or 1 or you need to start from minus 1. By looking at the expression, this is your y minima. So from here only you will get to know. If you put n equals to 0, then you are getting minus lambda by 4, which is not applicable because y value cannot be negative. Now if you put n equals to 1, then minus 3 lambda by 4, again it is not applicable. So you need to start putting negative value, minus 1. So if I put minus 1, what I am getting? Plus lambda by 4. So my minima location is coming plus lambda by 4. Then what I will put? N equals to minus 2. If you put n equals to minus 2, what you are getting? Minus 4 plus 1 minus 3, 3 lambda by 4. So in that manner you need to go. Okay, then 5 lambda by 4, these values you will get. So you must have got the maxima and minima. So first voltage maxima is occurring, then voltage minima, then voltage maxima, then voltage minima. Starting from here, maxima, then minima, then maxima, then minima. In that manner it is occurring. And what is the maximum and minimum value? What I am talking about, maximum value and minimum value. So what that would be? It would be V naught. Here there will be plus sign, so 4 by 3, or I can write 1 plus 1 by 3. And what will be the minimum value? V naught plus 1 minus 1 by 3. So this will be the minimum value. So 2 by 3 V naught plus, and this is your 4 by 3 V naught plus. That's it. Okay. So now you can draw the standing wave pattern for voltage. Let's analyze it for current as well. But again and again we will not analyze for current. Just in EM wave, what did we study? That first we analyze for electric field. We analyze the standing wave pattern for electric field. Then we get to know that magnetic field will be just opposite. That means where it was maxima, it would be minima. And where it is minima, this would be maxima. Same goes here. Where voltage maxima is there, current minima will be there. Okay. Why is that so? Because there is a negative sign, no? What I mean to say is that, what is your current expression? Now we are analyzing for current. So what is your IY expression? That is I naught plus e to the power j beta y plus I naught minus e to the power minus j beta y. Now what is the value of I naught minus upon I naught plus? That is gamma reflection coefficient at load, but for current. And what is the value for that? Negative of voltage reflection coefficient. So what is the voltage reflection coefficient? That is 1 by 3. So what will be the current reflection coefficient? Minus 1 by 3. So this we have already seen, the current reflection coefficient is negative of voltage reflection coefficient. So what you will be getting here? I naught plus e to the power j beta y minus 1 by 3 I naught plus e to the power minus j beta y. So from here what you are getting? I naught plus e to the power j beta y 1 minus 1 by 3 e to the power minus 2j beta y. And if I calculate the magnitude, what you will get? That would be I naught plus and magnitude of 1 minus 1 by 3 e to the power minus 2j beta y. From here if I ask maxima and minima, you can directly see here it was plus sign, but here it is minus sign. So you can directly see whatever the condition for maxima, this will become for minima, and whatever the condition was for minima, that would become for maxima. So where I will get my maxima and where I will get my minima. So what is the value of your maxima? Maxima you will get at minus 2 beta y. For maxima this should be minus 1. That means pi, 3 pi in that manner. So that should be equals to 2n plus 1 pi. So from here what is the value of y you will be getting? That would be lambda by 4, 3 lambda by 4. You can solve it. 2 beta will be 4 pi by lambda, then simply you need to put n equals to minus 1. From there you will get these values. So these will be 5 lambda by 4 and so on. And for minima, your minus 2 beta y should be equals to, for minima, this should be starting from 0 because cos 0 is 1. So 1, 2 pi in that manner. So 2n pi. So from here, what you will be getting? 0, lambda by 2, lambda, and in this manner. Okay. So location of voltage minima is the location of current maxima, and location of voltage maxima is the location of current minima. Right. Opposite thing is there. Ditto same thing is happening. What happened in E and H. So that's why I spent a lot of time in EM wave, because next things I wanted to make it cakewalk for you. So now transmission line is just a cakewalk for you, and it will be very, very easy if you have understood EM wave in a good manner, right? So what will be the maximum value and what will be the minimum value? So the maximum value will be here, for maximum value this would be -1, so maximum value will be I naught plus into 4 by 3, and minimum value will be I naught minus into 1 minus 1 by 3 would be 2 by 3. So what will be the standing wave ratio? This we can call current standing wave ratio, maximum by minimum. So what that would be? 2, and not I naught minus, sorry, here I naught plus only, here I wrote I naught plus, yeah. So if I write here voltage standing wave ratio, so what is the value of that? Maximum voltage divided by minimum voltage. So what you are getting? 4 by 3 divided by 2 by 3, so that is 2. What you are getting? 2. And here what you will get? 2 only. So from here what did you get to know? That your VSWR is equals to CSWR, voltage standing wave ratio, is equals to current standing wave ratio. This also you understood. Okay. Now let's draw the standing wave pattern. So for voltage, how did we start? Initially there was maxima, and maximum value was 4 by 3 and minimum value was 2 by 3. Sorry, here 4 by 3 and 2 by 3, and starting from maxima. So first we will start from maxima, then we get minima. Now it is very tough to make. Then again maxima, then again minima, then again maxima, then again minima, and in that manner you keep on going. Okay, and these locations you can mark out now: lambda by 4, lambda by 2, 3 lambda by 4, lambda, 5 lambda by 4. So starting from distance y, 0, lambda by 4, lambda by 2, 3 lambda by 4, lambda, 5 lambda by 4. Maximum value is, certainly we will compile the results, like in this condition what was the scene? ZL was greater than Z0. So these results also we need to combine. When ZL is greater than Z0, then your gamma voltage reflection coefficient, your voltage reflection coefficient was positive. If voltage reflection coefficient was positive, then at y equals to 0 you are having your voltage maxima. So this is your load, right? This is your load end. Y equals to 0 means load end, and you are going towards now sending end. From here you are going towards the source end. So at load you are getting the maxima. So certainly we will write down in conclusion whatever the results we are getting, but till now you just see the results. What we are getting: 4 by 3, this was 4 by 3 V0 plus, and this was 2 by 3 V0 plus. Same standing wave pattern for current also you can make, right? So for current reflection coefficient was negative. So first we are starting from minima. So these are just the results which you need to keep in mind while solving the problems. You will be able to solve the problem in a very easy manner and very early as well. Certainly we will write down the results, but we will see the cases first. All the required cases we will see. Then this typical topic will become very cakewalk for you, like a very, very easy topic it would become, if you just have given enough concentration, then only. Okay. So starting from minima, then we get maxima, then again minima, maxima, minima, maxima. And all the things are linked with the EM wave only. Same things are happening here, right? So this I can call as ISY magnitude, right? Here I could have called as VSY magnitude. So this is your 2 by 3 I naught plus 4 by 3 I naught plus. Okay, 0, lambda by 4, lambda by 2, 3 lambda by 4, lambda, 5 lambda by 4, and 3 lambda by 2. Okay, now what do you see? What is the distance between successive maxima and minima? Successive maxima and minima, what is the distance? Lambda by 4. Was it same for EM wave? Yes. And what is the distance between two consecutive maximas? Lambda by 2. And what is the distance between two consecutive minimas? Again lambda by 2. All these things were same for your EM wave as well, and same goes for voltage standing wave pattern as well. So is this clear to you? I hope you could have done this analysis on your own. The complete analysis you could have done on your own. If not, now you will do this analysis on your own. ZL is 25 ohm, rest all condition is same. So do it on your own now. Okay, so now I am starting. Voltage reflection coefficient first I will find. I will only draw the voltage standing wave pattern, because current standing wave pattern just will be opposite of that, right? So what will be my voltage reflection coefficient at load? That will be ZL minus Z0. And why I am finding at load? Because I know that my voltage reflection coefficient at load is equals to V0 minus divided by V0 plus, and that is equals to ZL minus Z0 upon ZL plus Z0. So minus 1 by 3, right? So this is your minus 1 by 3. Now I will write down my VSY equation directly. What it would be? V0 plus e to the power j beta y minus 1 by 3 V0 plus e to the power minus j beta y. So V0 plus e to the power j beta y 1 minus 1 by 3 e to the power minus 2j beta y. Okay, this is my VSY. And if you talk about the magnitude, then it would be V0 plus 1 minus 1 by 3 e to the power minus 2j beta y. From here only you can see the value of, you can see the location of maxima and minima, right? So again I will have to pick this VSY here, V0 plus 1 minus 1 by 3 e to the power minus 2j beta y. This we have already analyzed. You can see the location of maxima and minima. So wherever there was in the previous question, wherever there was maxima, it would be minima, and wherever there was minima, it would be maxima, right? Why it is happening? Because voltage reflection coefficient is negative. And why voltage reflection coefficient is negative? Because ZL is less than Z0. ZL is less than Z0. So all these results certainly we will compile, but let's see the maxima first. And here we will see minima. And here we can directly see the maximum and minimum values. So what is the maximum value? Maximum value and minimum value. So for maximum value plus would come. So V0 plus 1 by 3. That would be 4 by 3 V0 plus. And for minimum value minus would come. Or that would be 2 by 3 V0 plus. From here if you find current voltage standing wave ratio, what it is coming out to be? 4 by 3 divided by 2 by 3. That is 2 only. Okay. By the way, we can develop a formula as well. Okay, what I mean to say is that first let's find the location of maxima and minima. So minus 2 beta y is equals to, it should be equals to pi, right? Why it should be equals to pi? Because at pi this would be minus 1, so that's why you will get maxima there. So what is the value you are getting? Value of y you are getting is lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. And for this is your maxima. And for minima, it should be equals to 2 and pi. So what is the value of y you will be getting? From 0 you will start getting y minima we are writing. So 0, lambda by 2, lambda, 3 lambda by 2, and so on. Is that clear to you? Now what I was saying, you can develop a formula for voltage standing wave ratio. It will be same as your EM wave. What will be the formula? What do you think? You can see from here what I can write as my VSY. My VSY is V0 plus into 1 plus gamma L, right? 1 plus gamma L e to the power minus 2j beta y. This is what I am getting. This gamma L can have some, what I mean to say is that this gamma L can have some phase as well. Here it was coming minus 1 by 3. In the previous case, it was coming plus 1 by 3. But it can come as this manner as well, e to the power j theta. So in that manner also it can come. But then what will happen? Mode of this you will write, and then phase you will write here. But when you calculate the maximum value, then this will give you one value only. So what will be your maximum value? What do you think? From here, what I am writing here magnitude. Along with that, I need to write the phase as well. Because this gamma L can have the phase. In this question, what is the phase it is having? In this question, it is getting minus 1 by 3. So phase it is having is minus pi. Phase it is having is minus pi. These kind of examples we have already seen in that standing wave pattern video. So this can have a phase of minus pi as well. So here I am writing theta. So this can have the phase, but when you calculate the magnitude, at that time this will only give the phase. So this will not come into action for magnitude. So what will be the magnitude? 1 plus gamma L, and for minima it would be 1 minus gamma L. So your maximum value will be V naught plus 1 plus gamma L. Your maximum value will be V naught plus 1 plus mod of gamma L, and the minimum value will be V naught plus 1 minus mod of gamma L. This is your maximum value and this is your minimum value. So what will be your voltage standing wave ratio? That would be 1 plus mod of gamma L divided by 1 minus mod of gamma L, and that is equals to that current standing wave pattern, current standing wave ratio as well. So this formula we have already studied, right? 1 plus gamma L divided by 1 minus gamma L. We have already studied this formula, right? Okay. So this we have found for voltage maxima and minima. Similarly, opposite it would be for current maxima and minima, right? So now we can draw the standing wave pattern for voltage and current both. So what I can do is that I can just copy the standing wave pattern from previous part, because everything will be ditto same. So just I can copy the pattern. So this will be your current standing wave, voltage standing wave pattern. This time this will be your voltage standing wave pattern. So here I just need to replace VSY. This will be V naught plus. How did I do it? Initially you are having minima, starting from minima, maxima, minima, maxima. That's it. This is your voltage standing wave pattern. And for current standing wave pattern, what I need to copy? For current standing wave pattern, I need to copy this thing. This will be your ISY. This will be 4 by 3 I naught plus. This will be 2 by 3 I naught plus. Okay. So here initially there was voltage minima. So here it will be current maxima. Yeah, that's it. Okay. So what is my current standing wave ratio here? Current standing wave ratio. 4 by 3 divided by 2 by 3, that would be 2 only. And what is your voltage standing wave ratio here? That is also 2 only. So this pattern was made for ZL less than Z naught. For which condition? ZL less than Z naught. So for ZL less than Z naught, first current maxima is occurring. And previous one was made for ZL greater than Z naught. And in both of the cases, the load was resistive. This was made for ZL greater than Z naught. Now we can write down some conclusions for two cases, for these two cases. So that conclusion we will write down later on. First, let's write down some general conclusion. These are the general conclusions which will be applicable for everyone. That your current reflection coefficient will be negative of voltage reflection coefficient. The value of your standing wave pattern is 1 plus gamma divided by 1 minus gamma. Here mode of gamma, 1 plus mode of gamma divided by 1 minus mode of gamma. Now mode of gamma will be equal for all, right? Because this is just negative in sign. If I am getting voltage reflection coefficient as 1 by 3, then current reflection coefficient will be minus 1 by 3. But if I calculate mode of gamma, then both will be 1 by 3 only, right? And the distance between two local conjugative maxima is lambda by 2. Distance between two conjugative minima is lambda by 2. And distance between conjugative maxima and minima, that is lambda by 4. So these are the general results which will always be applicable. Now Vx by Vmax by V minimum, what it is called as S, right? This is known as S only. This is standing wave ratio. So Vx max by Vs minimum. So that will be equals to S, and that is equals to 1 plus gamma divided by 1 minus gamma. And I max by I min is also equals to S only. That is equals to 1 plus gamma divided by 1 minus gamma. Now when our load is resistive, here also ZL less than Z naught, but load was resistive only, no? ZL was resistive only. Here there was no inductor, nothing, there was no reactance. So when load is resistive, then certainly at y equals to 0, you will either get maxima or minima. In this case, you got minima. In the previous case, you got maxima. But certainly you will have maxima or minima here, no? So let's take this condition. Here you are having voltage minima and current maxima. So at load, at ZL, what you are having? Voltage minima and current maxima at load. So can you define ZL as this? My ZL can be defined for this case. For this case, my ZL can be defined as V minimum divided by I max. Why is that so? Because at the load, at ZL, what is happening? ZL is y equals to 0. ZL is y equals to 0. So at y equals to 0, whatever the current that you are getting, that is your I max. And whatever the voltage that you are getting, that is V min. So V min divided by I max is equals to ZL. Sorry, V min divided by I max. V min divided by I max. So V min divided by I max is your ZL. Because at the load you are having maximum current and minimum voltage. Okay. So can I write down this thing? And in the previous case, what will be the scene? Here ZL greater than Z naught. So at the load you are having V max and I min. So Vx divided by I min. Okay. So let's write it down. So relation between ZL, Z naught and standing wave ratio. What that relation will be, we will check it out. But how did I write down Vx by I min? How did I write it down? So this is my load ZL. This is my load ZL. So at load, when resistive load is there, so all these are applicable. All these things, this complete concept is applicable for resistive load only. So where should I write it down? Why it is applicable only for resistive load? Because later on in this video, we will see that when your load is inductive or when it is capacitive or when it is complex, at that time at y equals to 0, you will not have maxima or minima. That means at load, you will neither have maxima or minima. Maxima or minima will occur somewhere later on. Okay, so that we will see in this video only, but after some time. So this is applicable only for resistive loads. So if your load is resistive, then certainly at y equals to 0, either you will get maxima or minima. That's for sure, 100%. If your load is resistive, then 100% at y equals to 0, either you will get maxima or minima. When ZL was greater than Z naught, then we were getting voltage maxima and current minima. And when ZL is less than Z naught, at that time what we were getting? Current maxima and voltage minima at y equals to 0. I hope you are able to understand all these points. You are able to relate. If you are listening to the discussion carefully, then you will be able to relate. So this is applicable only for resistive load. For resistive load only. Because at resistive load only, at ZL you will get either Vmax or V min. But in this case, what we were getting? Vmax and I min. Which case is that? ZL greater than Z naught. This case is ZL greater than Z naught. Right? This case was ZL greater than Z naught when you were getting Vmax here and I min. And for ZL less than Z naught, what you were getting? For ZL less than Z naught, your voltage reflection coefficient was negative. If voltage reflection coefficient was negative, that means at load you were getting minima. This is my load ZL. So when voltage reflection coefficient was negative, so at load you are getting voltage minima and current maxima. So this will be your ZL equation. V min divided by I max. So this condition was for ZL less than Z naught. Now can I write it down in this manner? That my ZL is equals to V max by V min into V min by I min. Say yes or no. What will be V max by V min? V max by V min, that is equals to standing wave ratio S. You can say VSWR or CSWR. Basically, S I am writing as standing wave ratio. Okay, that is voltage standing wave ratio or current standing wave ratio. Both are same only, and that I am writing as S. So V max by V min is equals to S. What will be V min by I min? What do you think? Intrinsic, sorry, not intrinsic, characteristics impedance. Ratio of voltage and current. Ratio of forward voltage divided by forward current. What is your V min? Forget about this. What was your V min? Your V min was V naught plus into 1 minus gamma L, mod of gamma L. And what was your I min? Your I min was I naught plus 1 minus mod of gamma L. So this and this is getting cancelled. What is the value of V naught plus divided by I naught plus? Z naught only. So what you are getting? S Z naught. So your ZL is coming out to be S Z naught. In this case, what will happen? ZL is equals to, can I do in this manner? V min divided by V max into V max divided by I max. So what is V min by V max? 1 by S, right? So this is equals to 1 by S. What will be your V max? V naught plus into 1 minus gamma L, and what, sorry, 1 plus gamma L, and what is your I max? V naught plus I naught plus into 1 plus mod of gamma L. So this and this get cancelled, and what is the value of V naught plus divided by I naught plus? Z naught only. So what you are getting? ZL is equals to Z naught by S. So this formula will be very helpful for finding the ZL value. But how will you understand that which formula to apply? Either this formula you will apply or this formula you will apply. So you will see voltage reflection coefficient. If you get to know that my voltage reflection coefficient is positive, what I need to know is that if my voltage reflection coefficient is positive, that means at load I am having voltage maxima. And at load I am having voltage maxima. When do I have voltage maxima at load? When ZL is greater than Z naught. At load, if I am having voltage maxima, that means ZL is greater than Z naught, and that means my voltage reflection coefficient is positive, right? And if ZL is greater than Z naught, then which formula you will apply? ZL equals to S Z naught or Z naught by S? Because I know that S value will be greater than 1. What is the range of S? Range of S. What is the range of S? From 1 to infinity. This is the range of S, right? From 1 to infinity. In the standing wave pattern video only, in the last video we have seen the range of S is 1 to infinity. And what is the range of gamma? The range of gamma is minus 1 to 1. Range of gamma I or gamma V, whatever you can say, the range is minus 1 to 1. So here I am only writing gamma. So this is the range. And what is the range of mode of gamma? 0 to 1. So these ranges I already know. So S range is from 1 to infinity. So if I know that ZL is greater than Z naught, then which formula I will apply? This formula or this formula? Let us say S is 2. So ZL is equals to 2 Z naught. And here ZL is equals to Z naught by 2. So which formula you should apply? 2 Z naught. Why is that so? Because you know that ZL is greater than Z naught. And if you get to know that ZL is less than Z naught, then you will apply Z naught by S. And how will you understand that whether ZL is greater than Z naught or less than Z naught? By standing wave pattern. If you get to know that at y equals to 0, you are getting voltage maxima. That means voltage maxima you are getting. So certainly voltage reflection coefficient is positive. If voltage reflection coefficient is positive, that means ZL is greater than Z naught. That's it. Right? So if ZL is greater than Z naught, then you need to apply SZ naught formula. And when you get to know that at y equals to 0, that means at load I am getting current maxima. Current maxima means voltage minima. Voltage minima means voltage reflection coefficient is negative. Voltage reflection coefficient negative means ZL is less than Z naught. And ZL is less than Z naught means ZL is equals to Z naught by S. Like I will tell you, in these kind of concept, a lot of students are confused. Like those who get good ranks as well, they are also confused in these kind of questions. But we are seeing it in a very good manner. In very slowly we are seeing all these questions, all these patterns we will see very slowly, and all the patterns we will cover. So slowly we will proceed, but certainly we will never be confused in the problem. Whatever the statement would be written there, every single statement we will be able to understand, because we have seen the standing wave pattern very slowly, and we have actually seen the depth, and we are not mugging up a single formula there. Now we are mugging up the formula like 1 plus gamma divided by 1 minus gamma. This formula we will remember. ZL minus Z naught upon ZL plus Z naught. This formula we will remember. But for maxima and minima, we will never remember any formula. For maxima and minima, we will simply do this analysis. That's it. If you remember the formula, certainly you will mess it up. That's why I never ever tell you to remember formula for maxima and minima. This analysis you can do very easily in the examination, right? But if you remember the formula, this concept gets very complex. Okay, but it is not complex. We have seen it in a good manner. So we will write down the summary of previous two cases. What was the previous two cases? ZL greater than Z naught and ZL less than Z naught. But before that, let's see more cases. That ZL is equals to 0. This is one of the case. ZL is equals to 0. Then we will see ZL is equals to infinity. And then we will see ZL is equals to Z naught, matched load. So for all three cases, you can draw the standing wave pattern. Which three cases are there? First case was ZL greater than Z naught, ZL less than Z naught. That was the second case. Then we are going to start with ZL equals to 0, then we will see ZL is equals to infinity, and then we will see ZL equals to Z0. So for all these three, you can make the standing wave pattern. Then we will compile down the final conclusion. Okay, so do it on your own. Do it on your own. Just do it on your own. I will pause the video, take a break, and you do the you make the standing wave pattern for all the condition. You let me know what is the maximum value, what is the minimum value, and what all results you are getting. I will take a break, drink some water, and then I will come back. You can also do the same, and you come back after analyzing it on your own. Okay, thank you very much. Yeah, so let's restart and see this condition. So here first we will find the voltage reflection coefficient at load, that will be ZL minus Z0. So 0 minus 50 upon 0 plus 50. So that would be minus 1, right? And from here only, if I ask you what will be the standing wave ratio, so that would be 1 plus gamma upon 1 minus gamma, infinity. That means 1 will be some maximum value, but minimum value will be 0, because what this is equals to Vmax by Vmean. So certainly your Vmean has to be 0 only. This you can verify from here as well, or you can write down the equations as well. We will write down the equations as well. So what will be my Vy? My Vy will be V0 plus e to the power j beta y minus V0 plus e to the power minus j beta y. Why I am doing so? Why I put minus here? It would be plus V0 minus, but since it is this, since the reflection coefficient is minus 1, so it would be minus V0 plus, right? So from here Vy I can see is that V0 plus e to the power j beta y, if I take common, so 1 minus e to the power minus 2j beta y, and if I take the magnitude, that would become V0 plus, and here magnitude is 1 minus e to the power minus 2j beta y. So your magnitude here is, this is your magnitude. From here you can find the maxima and minima, along with that you can find maximum and minimum values as well. So maximum and minimum value directly I can see from here. For maximum value this guy will be 1, and for minimum value maximum and minimum value. So for maximum value this guy would be 1, sorry, for maximum value this guy would be minus 1, so 2 V0 plus, and for minimum this will be 1 only, so this will be 0. Okay, so 2 V0 plus and 0. Now I need to find the location of maxima and minima. So for location what I need to do? Maxima location and minima location. So for location minus 2 beta y, for maxima this should be equals to pi, multiple of pi. Why is that so? Not multiple of pi, 2n plus 1 pi. For maxima 2n plus 1. Why is that so? Because you need it to be minus 1. So for minus 1 pi, 3 pi, 5 pi, these you can have. So from here what will be the value you will be getting? So if you solve it up, what you are going to get? Lambda by 4, 3 lambda by 4, 5 lambda by 4 in this manner. And for minima, minus 2 beta y is equals to 2n pi. So if you solve it up, what you are going to get? 0 lambda by 2 lambda in this manner. So you will be starting with minima. You will be starting with voltage minima, and then maxima you will get. And in case of current, you will be starting with current maxima, because whatever that is happening in voltage, opposite will be happening in current. So this will be the waveform, right? You will be starting with voltage minima. In that manner you will go. And what is the maximum value? 2 V0 plus. Here what will be the maximum value of current? 2 I0 plus. But what is the standing wave ratio here? Current standing wave ratio, that would be equal to infinity. If you have studied this in a good manner, like we have spent roughly around 200 minutes on standing wave pattern, like 50 minutes here and 150 minutes in the previous video in EM wave. So this should have been solved. Like at least you should have been able to make this standing wave pattern. If you are not able to make, then this is concerning. But this standing wave pattern you should be able to make. You can directly see the voltage maxima and minima. With respect to that, you can see the current maxima minima as well. That would be just opposite, and from there you can get it. Okay. For open circuit load, voltage reflection coefficient ZL minus Z0 upon ZL plus Z0. Since ZL is very larger than Z0, so Z0 can be taken as 0. So what you will get? 1. Right? And if I ask you standing wave ratio from here only, what you are going to get? 1 plus 1 divided by 1 minus 1. So from here only you can tell standing wave ratio would be infinity. So if standing wave ratio is infinity, but you can find it down from Vy expression as well. V0 plus e to the power j beta y plus V0 plus e to the power minus j beta y. Why is that so? Because V0 plus will be equal to V0 minus. So V0 plus e to the power j beta y 1 plus e to the power minus 2j beta y. And if you talk about the magnitude of Vy, if you talk about the magnitude, so directly I can see the magnitude will be 1 plus e to the power 2j beta y. And maxima minima I can see for maxima and minima, maximum value and minimum value, maximum value and minimum value. If I talk about the value, so this should be 1 for maximum value, so 2 V naught plus, and for minimum value this should be minus 1, so 0. And if I find the location of maxima and minima, I will only find the location of maxima, because for minima I know lambda by 4 distance would be there, so only I find the value of maxima. So only I am finding the value of maxima. So how will I find that my minus 2 beta y? So for maxima it should be 0, 2 pi in that manner, so 2 n pi. So y is equals to minus n lambda by 2. So from here you can put the values. So what you are going to get, your y maxima is 0, lambda by 2, lambda, 3 lambda by 2, and so on. So this is your maxima. From here what will you get to know, that what will be your minima? So minima cannot start from minus lambda by 4, so it has to start from plus lambda by 4. So lambda by 4, 3 lambda by 4, 5 lambda by 4 in this manner. So this you have found for voltage, and for current simply it will be opposite. So if you just find voltage maxima, you can tell voltage minima, you can tell current maxima and current minima as well, right? So you will be starting, this will be your voltage maxima. So for starting with maxima at y equals to 0, you are having maxima. So this is the location of maxima. So you will be starting with maxima and then you will be going down. And what will be this magnitude? 2 V naught plus. And what will be this magnitude? That would be 2 I naught plus. What will be your CSWR? That would be equals to VSWR, and that you can directly see as infinity, right? So what did you see here? For open circuit load and short circuit load, for both of the cases, your mode of gamma will be 1. Your mode of reflection coefficient will be 1. And if mode of reflection coefficient is 1, that means certainly your standing wave ratio will be infinity. And if your standing wave ratio is infinity, then that means minimum value you will have 0. But in the previous cases, ZL less than Z naught, at that time your voltage reflection coefficient was not unity. Here voltage reflection coefficient was not unity, it was some 1 by 3. If it is some value, then certainly it will not be infinity. So it was not infinity. But in all the cases, for resistive load, in all the cases, at load either you are having maxima or minima. Let's see all the patterns. Starting from here, at load you are having voltage maxima, at load you are having current minima, at load you are having voltage minima, at load you are having current maxima. Here, at load you are having voltage minima, current maxima. At load you are having voltage maxima, current minima. So either voltage maxima you are having, or current maxima you are having, or voltage minima you are having, or current minima you are having. So in case of resistive load, certainly at y equals to 0 or at load, either you will have maxima or minima. That means there will be something conclusive at the load, right? So this is another important result. And what was the other result? That if ZL is greater than Z naught or ZL is less than Z naught, then your VSWR is some finite value. But if short circuit load is there or open circuit load is there, then my gamma would be 1 and my VSWR will be infinity. You can think all these things in the examination, that okay sir, ZL is greater than Z naught, that means ZL is not 0. If ZL is not 0, then gamma will be positive. If gamma is positive, that means my voltage maximum will occur. Now since this is a resistive load, so certainly at load something will occur. What will occur? Voltage maximum will occur. Now what next thing you will see, that sir, ZL is greater than Z naught, that means gamma will not be unity. If gamma is not unity, that means my voltage standing wave ratio will be some finite value, it will not be infinity. And if it is some finite value, that means minimum value will not be equal to 0. So these conclusions you can make. Certainly we will write it down and we will also see what kind of questions are asked. Now what about this? ZL is equals to Z naught, matched load. This is known as matched load. So what will be your gamma L? That would be 50 minus 50 upon 50 plus 50. So the gamma L will be 0. So there is no reflected wave, and if there is no reflected wave, that means there is no standing wave pattern. What do I mean to say is that standing wave ratio I will not even define, right? Or you can define it as well. You can say that standing wave ratio will be 1, because 1 plus gamma upon 1 minus gamma. You can say standing wave ratio is 1. And what do I mean by that? That V maximum and V minimum are equal only. Basically, what will be your Vy? Vy will be V naught plus e to the power j beta y plus 0 into V naught minus 0 into, here you write 0 into V naught plus e to the power minus j beta y. So this will be 0 only. So Vy is, you are getting is V naught plus e to the power j beta y. So there is no reflected wave, no reflected wave, no reflected wave. That means there is no standing wave pattern, because for standing wave pattern there should be incident wave and reflected wave. If there is only incident wave, that means this is a traveling wave. But if there is incident and reflected wave, both superimposing will make a standing wave. So there is no standing wave, no standing wave. Okay, let's see the conclusion now. So this condition we saw, first we saw this condition, ZL is greater than Z naught. So at that time your gamma V was positive, right? It was real and positive, real and positive. It was 1 by 3, it could be any value. ZL is greater than Z naught, that means it was real and positive. What was the standing wave pattern? What is written here behind? VSWR is written. So here we will be commenting about VSWR. Okay, here we are commenting about VSWR. Yeah, so real and positive. What was the standing wave pattern? In the standing wave pattern, what you could see, voltage maxima at load, right? Because gamma L, voltage reflection coefficient. What is this? This is your voltage reflection coefficient. If voltage reflection coefficient is positive and load is resistive, nature of load resistive, all these are resistive load. Okay, so voltage reflection coefficient it was. So if nature of the load is resistive, that means certainly at load you will have something conclusive. What conclusion you can make? If ZL is greater than Z naught, that means gamma V is positive. If gamma V is positive, that means certainly you will have voltage maxima at load. Voltage maxima at load. And this voltage reflection coefficient is not equals to 1, right? This voltage reflection coefficient was not equals to 1 here. That means certainly your VSWR will not be equals to infinity. That means your V minima will not be equals to 0. Is it correct or not? It would be some finite value. Your standing wave ratio S will be some finite value. If it is some finite value, that means certainly your V minimum cannot be equals to 0. Okay, so these conclusions, because in the examination what they will give is that they will make some pattern, they will just make some pattern and they will ask you what is the nature of the load. So there you need to know these conclusions and you don't need to mug it up, you just need to think, that's it. Okay, and how to think, that also I am telling, and we will see these kind of questions as well. So do not worry, what all kind of questions can be asked in the examination, every single pattern we are going to cover. So ZL is equals to 0. If ZL is equals to 0, after that we saw this condition, so let's talk about this condition now. ZL is less than Z naught. So if ZL is less than Z naught, then certainly it will be negative and certainly it will not be equals to 1. What will be the nature? Nature will be real and negative. And if it is negative, that means certainly voltage minima will be occurring at load, or you can say current maxima at load. What about VSWR? VSWR will not be equals to infinity, and if it is not equals to infinity, that means your certainly your V minimum is not equals to 0. Okay, ZL is equals to Z naught. When ZL was equals to Z naught, then your gamma V was 0. What you will write as nature, it is 0 only. So certainly it is 0. There was no standing wave pattern and standing wave ratio was 1. Like 1 plus gamma upon 1 minus gamma, 1 plus 0 divided by 1 minus 0. So standing wave ratio was 1. Now when ZL was 0, so at that time, what do you think? What will be gamma V? Like you don't need to go to the previous pages to see the conclusion. You can think, if ZL is equals to 0, that means what will be your gamma V? Gamma V will be minus 1. Because ZL is 0, 0 minus Z naught upon 0 plus Z naught. If gamma V is minus 1, that means what will be the nature of gamma V? That is real and negative. Real and negative. And if it is negative, that means current maxima at load. And what we are writing here, we are writing about VSWR. So here your VSWR will be equals to infinity. Why is that so? Because mode of gamma V is equals to 1. So 1 plus 1 divided by 1 minus 1. So that would be 2 divided by 0. That would be equals to infinity. And if it is infinity, that means certainly my V minimum is equals to 0. Right? And let's see this condition. If ZL is equals to infinity, then my gamma V was 1. It is real and positive. Okay, so here if it is positive, that means certainly voltage maxima at load. And what about VSWR? If it is 1, then certainly VSWR is equal to infinity. And if it is equals to infinity, that means V minimum is equal to 0. That's it. There you go. Okay. So this is all about resistive load. In resistive load, only these 5 kind of condition can be there. ZL less than Z naught, ZL greater than Z naught, ZL equals to 0, ZL equals to infinity, and ZL equals to Z naught. Now we will see inductive load, capacitive load, complex load, these conditions we will see. So you try analyzing it on your own. You can do it, certainly you can do it on your own. What you will do, you will first find reflection coefficient, gamma. Then you will write down the voltage equation. Then you will see the gamma will have some angle. So how that angle will come into action, from there you can find out the maxima and minima. So do it on your own. Again, I need to pause. Okay, I will come back. I need to pause. I just got some work. So then I will pause again. I will explain this thing. Very easy thing. Like the same analysis we just need to do, and we will get the standing wave pattern. So you let me know what will be the location of voltage maxima. Okay, what you need to know, what you need to tell me, what is the first location of voltage maxima? What is the first location of voltage maxima? Okay, that you need to tell me. And same you can do for capacitive load as well. So capacitive load is minus J50. So for this, if you are able to make the standing wave pattern for this one, then certainly you will be able to make the standing wave pattern for this one as well. Okay, something conclusive you will see. So we will draw the standing wave pattern, and then we will write down the conclusion. Then we will see for resistor plus inductor, and then we will see for resistor plus capacitor. So all these conditions, whatever that can be asked, all the conditions we have seen, and no questions apart from these conditions can be asked in your examination. That's for sure. They can make this as complex, but if they make this as complex, that means this is a lossy medium. And I told you in the previous video only, when we were studying standing wave pattern for EM wave, for lossy medium it would be very tough to analyze. So they will not ask. They will ask only for lossless. Till now, 100% question has been asked only on lossless only. Okay. So they will ask on lossless. But even if they ask on lossy, I told you what will happen. It will keep on decreasing in this manner, right? So yeah, we will see. Let's take a break. Again, this was only 15 minutes only. So I am taking a break. You don't need to take a break because I got some work. Then I will come back and I will start it. Okay. So let's start for inductive load. Yeah. So let's start the analysis for inductive load now. Okay. So first what we need to find the reflection coefficient at load. So that will be ZL minus Z naught, J50 minus 50 divided by J50 plus 50. Now you know one thing, it will have a magnitude as well as it will have some angle as well, right? Because there is J term. What will be the magnitude? If I only talk about the magnitude, so directly I can see here, if I take 50 outward, what I can do is that I can take 50 outward first. 50 I can take outward because 50 is getting cancelled. So J minus 1 upon J plus 1 I am getting. Okay. Now let's talk about the magnitude. So how will you calculate magnitude? For upper one, it would be 1 square plus 1 square, or you can say 1 square plus minus 1 square. 1 square plus minus 1 square divided by 1 square plus 1 square. What you are getting? Under root 2 by 2. Under root 2 by under root 2. What you are getting? 1. And that's for sure. Always you will get 1. What I mean to say is that your gamma L could be JXL minus Z naught upon JXL plus Z naught. What I am saying is that my impedance is JXL. So what will be the magnitude of this? XL square plus Z naught square divided by under root XL square plus Z naught square. This I am writing magnitude. Okay. Forget about the angle. Angle will come later on, but if I only write down the magnitude. So XL square plus Z naught square divided by under root XL square plus Z naught square. So magnitude will be 1 only. There is no doubt about that. We need to find angle. So magnitude will always be 1. If magnitude is always 1, that means what will be your standing wave ratio? 1 plus 1 divided by 1 minus 1. Standing wave ratio will always be infinity. That means my V minimum will be 0. Another conclusion I have made. If my load is purely inductive, then certainly my mode of gamma L will be 1 and my S will be equals to infinity and my V minimum will be equals to 0, or I minimum will be equals to 0. But let's find out the angle now. Angle of gamma L. How will I find out? What is the angle of J minus 1? J minus 1. So minus 1 here and plus J here. So this angle I need to find. This will be 45. So angle will be 135 in anti-clockwise direction, right? Because this is J, this is minus 1. So in second quadrant I am. So 180 minus 45, 135. So upper angle is 135. just a second. Yeah, sorry for the interruption. So I was writing down the angle. So angle 135 for this, and what will be the angle for this? J plus 1. J plus 1. So 1 here, J here. So this will be 45 degree, right? So 135 minus 45, since it is in denominator. So if it comes upward, so minus 45. So what is the angle? 90 degree. So now how you can write your gamma L? Gamma VL we are writing actually. This is voltage reflection coefficient we are calculating. So that is magnitude is 1 and angle is 90 degree. So this is how I can write down my gamma L now. So this is always the first task while solving any problem related to our standing wave pattern. Now I will write down the equation. So what will be my Vy? Vy would be V naught plus e to the power j beta y plus V naught minus. What will be V naught minus? V naught minus will be gamma VL, that is 1 into e to the power j 90 degree. This is my V naught minus e to the power minus j beta y. Okay. And here, certainly here V naught plus will also come. Basically, what is your, I hope you have understood what we are doing here. V naught minus divided by V naught plus. What is that? That is your gamma L. And what is V naught minus? V naught minus is gamma L into V naught plus. And what is your gamma L? Gamma L is 1 into e to the power 90 degree. And then it would be V naught plus. This will be your V naught minus. Okay. So what I can take outward? Into 1 plus e to the power j 90 degree to the power minus 2j beta y. So if I calculate the magnitude, what is the magnitude we are getting? This kind of analysis we have already done when we were studying our EM wave. So that's why it is very easy for us. E to the power j, now minus 2 beta y plus pi by 2, right? Minus 2 beta y plus pi by 2. Now I need to find maximum and minimum value, maxima and minima. These things I need to find. Maxima and minima. Minus 2 beta y plus pi by 2. For maxima, what this should be equals to? 2 and pi, because 0, 2 pi, 4 pi should be equals to 2 and pi. And for minima, what this should be equals to? Although you don't need to calculate it, because lambda by 4 difference would be there. This you already know, but let's calculate it. So what you are going to get? 2n plus 1 pi, right? So if you solve it up, so how you can solve it? What you need to find? You need to find the value of y. So what I can do is that pi by 2 minus 2n pi divided by 2 beta, that is 4 pi by lambda, is equals to y. So y is equals to 1 minus 4n, 1 minus 4n divided by 8, okay, into lambda. So now you can start putting the value. N equals to 0 if you put, applicable, because lambda by 8 positive value you are getting. If you put n equals to 1, minus 3 lambda by 8 you are getting, which is not applicable. So n equals to minus 1 you need to put. So what will be the first one? N equals to 0, lambda by 8. Then n equals to minus 1 I will put. Here I will put negative values. So if I put minus 1, what I am getting? 5 lambda by 8. Then in that manner it will keep on going. So next will be 9 lambda by 8. Okay. And from here only I can tell you the value, I can tell you the location of minima. What will be the location of minima? It would be plus minus lambda by 4. Either it would be minus lambda by 4 or it would be plus lambda by 4. So first we will check for minus lambda by 4. If I checked for minus lambda by 4, what I am getting to know? That it is coming out to be minus lambda by 8, which is not possible. It has to be positive then. So first voltage maxima is occurring, after that lambda by 8 plus lambda by 4 distance, our voltage minima would occur. So what will be the location? 3 lambda by 8. So the location will be 3 lambda by 8. So from here also you can get to know that our location of minima will be 3 lambda by 8. Then lambda by 4 will keep on adding. What will keep on adding? Lambda by 4. Or you can say, sorry, not lambda by 4, lambda by 2 will keep on adding. Because between two successive minima, the distance will be lambda by 2. So lambda by 2 will keep on adding, or you can say 4 lambda by 8 will keep on adding. So 7 lambda by 8, then 11 lambda by 8. In that manner, it will keep on going. Okay. And I can solve from here as well. If I solve from here, then what will happen? This is 2n pi. So minus 2n pi minus pi plus pi by 2 is equals to 4 pi by lambda y. Okay. So from here what I am getting, so this is your minus pi by 2 only. If it is minus pi by 2, so minus sign I can take outward. So lambda by 4 and minus 2 and pi and minus pi by 2, right? Minus 2 and pi and minus pi by 2. So minus 4 and minus 1 divided by 2. Okay. So lambda by 8 minus lambda by 8 minus lambda by 8, 4n plus 1. Certainly you cannot put n equals to 0, 1, 2, 3. Why you cannot put? Because negative value you will get. So what you will put? N equals to minus 1. If you put n equals to minus 1, what you are getting? 3 lambda by 8. So yes, this is the first one. Then ahead you can put n equals to minus 2. If you put n equals to minus 2, what you are getting? 7 lambda by 8. Okay. So in that manner you can proceed, and these are your location of minima. So this is your maxima and this is your minima. And if I know the voltage standing wave pattern, then I can draw the current standing wave pattern as well, right? Because where voltage maxima is there, there will be current minima, and where voltage minima is there, that there would be current maxima. So what is occurring first? Voltage maxima is occurring first. Now at y equals to 0, there will be some value. Whatever the value is there, I don't know, or I can find out as well. I will put y equals to 0 here. At y equals to 0, what you will be having? If I put y equals to 0 here, then my Vy would be, if I put y equals to 0, if I put y equals to 0, so it will be e to the power j pi by 2. And what is e to the power j pi by 2? E to the power j pi by 2 is j only, right? E to the power j pi by 2. So cos theta plus iota sin theta, or j sin theta. So cos theta is 0, j, only j will be left. So it will be 1 plus j. So it will be v naught plus and magnitude of 1 plus j. And what is the magnitude of 1 plus j? Under root 2 v naught plus. So at y equals to 0, you are having under root 2 v naught plus. And what is the maximum value and minimum value? Maximum value is, if I talk about maximum value, okay, and minimum value. So what is the maximum value? For maximum value, this will be equals to 1. So 2 v naught plus. And for minimum value, this will be equals to minus 1. So 1 minus 1, 0. So maximum value is 2 v naught plus, which is occurring at lambda by 8. At y equals to 0, what you are having? Under root 2 v naught plus, which is not the maximum value. So this is how your standing wave pattern will look like. This value is under root 2 v naught plus, but maximum value is occurring at lambda by 8, which is equals to 2 v naught plus, and minimum value is 0. So starting with lambda by 8, then at 3 lambda by 8 you are having minima, then 5 lambda by 8 again maxima and minima, and distance is between successive minima and maxima, distance is lambda by 4. Between two successive maximas, the distance is lambda by 2, and between two successive minimas, this is also minima, this is also minima, the distance is lambda by 2 only. So this kind of analysis we can see. Okay, and for current waveform, what will be happening? Exactly the opposite thing will be happening. Okay, exactly the opposite thing. But what will be the magnitude? Magnitude will be under root 2 I naught plus divided by z naught. No, sorry, I naught plus. You can say under root 2 I naught plus will be the magnitude. And what is I naught plus? I naught plus is v naught plus by z naught. Here at y equals to 0, you are having under root 2 v naught plus. This will have under root 2 I naught plus, right? And if you need to show it in terms of v naught, if you need to show it in terms of v naught plus, then you will say under root 2 v naught plus divided by z naught. Okay, and what will be the maximum one? Maximum will be 2 I naught plus, because maximum and minimum values does not change. It will be 2 I naught plus and minimum will be 0. Just location of maximum minima is interchanged. Okay, so this is the standing wave pattern. So from here, what conclusion you are making? If my load is purely inductive, load is purely inductive. Purely inductive means there is no resistor term. 50 ohm, those terms are not there. So if my load is purely inductive, then first my voltage maxima is occurring. If load is inductive, so first inductive, so first voltage maxima will occur. How you can remember it? Do you remember V is equals to IR? What is IR? Like what is the impedance provided by the inductor? J omega L. What is the impedance provided by the inductor? That is J omega L. So if you write down the Ohm's law, V is equals to I into impedance provided by the inductance, that is J omega L. So who leads? Voltage leads. In case of inductor, voltage lead current. V leads current. So similarly in the standing wave pattern as well, first voltage maximum will occur and then current maximum will occur. First voltage maximum will occur and then current maximum will occur. How will you remember this thing? V is equals to I j omega L. That means voltage leads the current in case of inductor. That means certainly first voltage maximum will occur in case of inductive load. That's it. This is how I remember it, and you can also remember in the same manner. So what is the conclusion we can see is that first conclusion is that our standing wave ratio VSWR, that is equals to CSWR, and that is equals to S, which is infinity. So this is the first conclusion, and second conclusion is that first voltage maxima is occurring. So that we are going to write down. So when load is purely inductive, so what is the first thing? First thing is that your mode of gamma L will be 1. If I talk about mode of gamma L, what that would be? From here under root XL square plus Z naught square upon under root XL square plus Z naught square. So mode of gamma L will be 1. So from here I can get to know that my S will be equals to infinity, and from here I can tell that my I minimum and V minimum both will be equals to 0. So my standing wave ratio will always be equals to infinity. At y equals to 0, there will be no maxima, no minima, you cannot conclude. At y equals to 0, there will be no maxima, no minima, there will be some value. And first voltage maxima or current minima will occur. So first voltage maxima or current minima will occur. So if this kind of standing wave pattern is given, you will get to know that certainly the load is inductive. Say yes or no. Now what do you think what will happen in capacitive load? In capacitive load, first voltage minima will occur and current maxima will occur. Okay. So these kind of results are very important, like very important, I would say. And people just mug it up, they don't even understand it. But now we are understanding every single thing. I will just turn on the charger and then I will come back. Otherwise the screen is lagging. Yeah, so let's start solving this one. You can start solving it on your own. Write down the phase and all those things you write down the magnitude. From magnitude as well, here also you will get to know that magnitude is always 1. So gamma VL I am writing ZL minus Z naught upon ZL plus Z naught. So if I write down the magnitude, I can directly see it is, or what I can do first is that I will take, here I am taking minus 50 common, okay. What I am taking common? Minus 50. So J plus 1 divided by, here also I am taking minus 50 common. So J minus 1. Okay, minus 50 I took common, J plus 1, and here also minus 50 I took common, J minus 1. So what we are getting? Gamma VL is equals to J plus 1 upon J minus 1. And if I ask you the magnitude, that would be 1. And if I ask you the angle, what that would be? What J plus 1 will provide? 45 degree. And what J minus 1 will provide? J minus 1. That means second quadrant. Minus 1 and J, that would be 135 degree. So minus 135 degree. So what you are getting? Minus 90 degree. So if I write down gamma VL, that would be minus J. Okay. Okay, fine. And now for any inductive load, for any capacitive load, what I can say is that my impedance can be of this form, minus JXC. So ZL minus Z naught upon ZL plus Z naught. So if I calculate the magnitude, what it would be? Minus XC square, that would be XC square only. Plus minus Z naught square, that would be Z naught square only, upon XC square plus Z naught square. So that would be equals to 1 only if I am talking about the magnitude. So this I talked about magnitude. This I talked about the magnitude. Okay, angle is a separate thing, but here magnitude is always 1. That means certainly my standing wave ratio, current standing wave ratio or voltage standing wave ratio will be equals to infinity only. So my standing wave ratio will always be equals to infinity, and this is my gamma VL, that is minus J. Okay, and if I write down my Vy equation, can I write it down? Certainly I can write down. That would be V naught plus e to the power J beta y, and here it is minus J. So minus J V naught plus e to the power minus J beta y. So what common I can take? V naught plus e to the power J beta y, 1 minus J e to the power minus 2 J beta y, and J, instead of writing it as a J, I am writing magnitude is 1. Like you might be getting confused that how did I write it at as minus J, because minus 90 degree is minus J only, or you could have written gamma VL is equals to magnitude is 1 and angle is minus 90 degree. Okay, in that manner you could have written. So if you solve this, you will get minus j only. So here let's write it in this manner only. So magnitude is 1, and angle is e to the power minus j90, okay, and e to the power minus j beta y, and certainly v naught plus will also come, so that I cannot forget. So v naught plus e to the power j beta y, 1 plus e to the power minus j90 e to the power minus 2j beta y, okay. So from here if I calculate the magnitude, that would be v naught plus, and here 1 plus e to the power j minus sign is there, 2 beta y plus 90 degree. Are you getting this point? What we are doing? E to the power minus j, minus sign also I can take inside only, because e to the power j theta result I know. So e to the power j, let's take minus sign here only. E to the power minus j 2 beta y plus 90 degree. So this is very easy. This you can see. From here I can find out the maximum and minimum value, or maxima and minima as well I can find. If I find out the maximum value and minimum value, so what will be the maximum value and minimum value? For maximum value this will be 1, so 2 v naught plus, and for minimum value this would be minus 1, so this will be 0, okay. Now you find maxima and minima, okay. So minus 2 beta y plus pi by 2, for maxima this should be equals to what? So this should be equals to your 2n pi, because 0, 2 pi, 4 pi, that would give you cos 1. So this should be equals to 2n pi. So from here what you are getting? Minus pi by 2 minus 2n pi, right? This is minus pi by 2 is equals to 2 beta y. So minus 1 plus 4n by 2 pi is equals to 4 pi by lambda, lambda by 8. So minus lambda by 8, so y is equals to minus lambda by 8, 1 plus 4n. So can you put n equals to 0? No. Which is the first one you can put? Can you put n equals to 1? No. So what you will put? N equals to minus 1 you will put. So what you are getting? 3 lambda by 8. So first location of maxima you are getting, this is the maxima. So first location of maxima you are getting is 3 lambda by 8. Then lambda by 2 will keep on adding, or you can put n equals to minus 2. If you put n equals to minus 2, what you are getting? 7 lambda by 8. Then 11 lambda by 8. In that manner it will keep on going. Now this is the location of first maxima. Then minima could be at minus lambda by 4 or plus lambda by 4. So if I check at minus lambda by 4, what I am getting? Lambda by 8, which is a positive value. So this is acceptable. So your minima will be at, first minima will be at lambda by 8. From maxima, if you need minima, then what you need to do? Either you will check minus lambda by 4 or you will check plus lambda by 4. When I check minus lambda by 4, I am getting lambda by 8, which is acceptable because this is a positive value. So this is acceptable. So this will be into my answer. Or you can check from other method as well, but from here only I will get to know that what will be my minima location. So my minima location first will be at lambda by 8. Then what I need to do? From here I need to keep on adding 4 lambda by 8, or you can say lambda by 2. So 5 lambda by 8 I will get. Then 9 lambda by 8 I will get. So in that manner I will get. So first what you are getting? You are getting voltage minima, and voltage minima you are getting at lambda by 8. That means at y equals to 0 you are having a certain value. At y equals to 0 you are neither having maxima nor having minima. So you are having a certain value. What value you are having? So let's check that out. At y equals to 0. At y equals to 0. So V0. So this would be V naught plus into 1. If you put y equals to 0, so e to the power minus j90. So that would be minus j. So that would be under root 2 V naught plus. So what this value will be? Under root 2 V naught plus. Okay. So at y equals to 0, you are having under root 2 V naught plus only. But initially you are having minima. So first voltage minima will occur. So if I draw the waveform for voltage waveform, if I draw the voltage standing wave pattern, so at y equals to 0 you are having under root 2 V naught plus, then minimum value. What is the minimum value? Minimum value will be 0 only. And after that maximum will occur. And if voltage minima is occurring first, that means current maximum will occur first. And what will be this value? This will be equals to 2 I naught plus only. Okay, and then 0. And what will be this value? Under root 2 I naught plus. Are you getting this point or not? All these points should be crystal clear to you. And what is the standing wave ratio? Whether it is current or whether it is voltage, that is equals to infinity. So in case of capacitive load, pure capacitive load. So in the examination, what you would think? Okay, pure capacitive load is there. Minus jXC would be there. That means gamma VL will be equals to 1. If gamma VL is equals to 1, that means VSWR is equals to infinity. And if VSWR is equals to infinity, that means certainly I am having V minimum equals to 0 and I minimum equals to 0. Now what you will think? Okay, this is not resistive load. This is some capacitive or inductive load. So if it is a capacitive load, that means certainly at y equals to 0, I am neither having minima nor I am having maxima. So at y equals to 0, I cannot comment neither minima nor maxima. But what will occur first? Since it is capacitive, so in capacitive load, current will lead. That means current will have voltage, current maxima will occur first, and then voltage maxima will occur. So first current maxima will occur, and then voltage maxima will occur. What I mean to say is that this is your capacitor, right? And this is the voltage, and if you write down the current, what you will write down? V is equals to I by j omega c. So V is equals to minus j I by omega c. That means voltage is lagging behind current by 90 degree. Voltage lags behind. Voltage is lagging behind. And current leads. So current is leading. That means first current maxima will occur. So this is the way to remember in a longer run. Or in the standing wave pattern as well, you can remember. So in case of capacitive load, what is the conclusion? That always, if you calculate your gamma VL, that would always be equals to 1. That means my standing wave ratio will always be equals to infinity. At y equals to 0, you will neither have a maxima or minima, but first current maxima will occur, or you can say voltage minima will occur. So now what did you understand? When your load is resistive, then at y equals to 0 only you will have maxima or minima. But if you are not having maxima or minima at y equals to 0, that means certainly your load is not resistive. It could be inductive, it could be capacitive, or it could be complex. So this condition also we will solve. My ZL is 25 plus 50J. So it is complex, but it is resistor plus inductor, right? This is the resistor plus inductor. This we have already seen in the last videos only. This is the resistor plus inductor. So this condition also we need to solve. So here also you will not get your maxima or minima at y equals to 0. In this condition as well, you will not get maxima or minima at y equals to 0. At some other point only you will get your maxima or minima. So what that other point would be, like this diagram would be given in the examination, and they will ask you find the location of first voltage minima or first voltage maxima. So these kind of questions can be asked. Okay. So now what I'm gonna do is that gamma VL, ZL minus Z naught, ZL minus Z naught upon ZL plus Z naught. So minus 25 plus 50J divided by 75 plus 50J. So what you can do is that I can take 25 common. So 2J minus 1 divided by 2J plus 3. Right? If I take 25 common, what you are getting? 2J minus 1 divided by 2J plus 3. So this is your gamma VL. So mode of gamma VL is equals to under root 5 divided by under root 13. No, 9 plus 4 and 4 plus 1. 4 plus 1 5, 9 plus 4 13. Okay, so what we are getting? Under root 5 by 13. Okay, let it be. And if you write down the angle, so for that I guess I will need the calculator. So I need to this is in minus 1 plus 2J. So this is in your second quadrant only. So first you will do tan inverse 2. Tan inverse 2. But then you need to subtract from minus 180. So that you are getting 116.56 minus. Then you need to subtract this angle, that is 2 by 3. 2 by 3 tan inverse. So which is 33.69. So what you are getting? Minus 116 0.56, 82.86, 82.86. Let me check it again. 2j minus 1 and 2j plus 3. So 2 tan inverse minus 180 minus 2 tan inverse 116, and then 2 by 3 tan inverse. So 33.69 minus 116.53. So 82.83 actually. 82.83 or 84, whatever I can write. 85 I am writing. So here your mode of gamma VL is not equals to 1. So certainly your VSWR will not be equals to infinity. What I mean to say is that here your mode of gamma VL will never be equals to 1. So certainly your VSWR is not equals to infinity. That means your voltage minimum will not be equals to 0, and neither your current minimum will be equals to 0. Okay. So you are able to differentiate the things now. Like you don't need to mug it up everything, but you will be able to differentiate that, sir, if my load is complex, then my V minimum will not be 0. So if some standing wave pattern is made, like this, then just by looking at the pattern, you will get to know that the load cannot be complex. Because in complex load, your mode of gamma VL will never be equals to 1. And if it is never equals to 1, that means minimum value can never be equals to 0. So that option you will eradicate. Then you will think of resistive load or capacitive load or inductive load. And then there you will start thinking. Then you will see that at y equals to 0, that means at load, if you are having something conclusive, if you are not having anything conclusive at load, that means load cannot be resistive. That means there are two options left, inductive or capacitive. Then you will see which is occurring first. Voltage maxima is occurring first, that means it is inductive load. So in that manner we will analyze. So these kind of questions are very famous and very, very important. So here, yeah, this is what we are getting. So our gamma VL can be written as under root 5 by 13 e to the power j 82.85 degree. Okay. Now if I write down my Vy equation, so V naught plus e to the power j beta y plus under root 5 by 13 V naught minus e to the power minus j beta y e to the power j 82.85 degree. So V naught plus e to the power j beta y to 1 plus here y V naught minus, it will be V naught plus only, no, under root 5 by 13 e to the power j 82.85 minus 2 beta y, right? This would be, if I take e to the power j beta y outward, then here it would be e to the power minus 2j beta y and 82.85 degrees there. Okay. Now if I ask you maxima and minima, so maxima and minima you need to tell. So I will only calculate maxima. From there I can get the value. From there I can get minima as well. So let's calculate the maxima. So 82.5, 82.85. This is in degree, and this I will write in radian. So let's keep it in degree only. 82.85. 82.85. But if I ask you maximum and minimum value, then can you write down? Yes, certainly I can write down. What will be the maximum value? V naught plus 1 plus under root 5 by 13, and for minimum value it would be V naught plus 1 minus under root 5 by 13. Okay. And for maxima, and here I will write minima. So for maximum minus 2 beta y. So in case of maxima, this should be equals to 2n pi. Right. So 2n pi goes here, 82.85 minus 2n pi. Can I write it down as, if I need to write down in degree? So what is 2 pi? 360. Right. So 360 degree n. This is what I can write down, is equals to 4 pi by lambda into y. So what I can write down as 4 pi? My 4 pi could be 720 degree. All I am converting into degrees, or you can convert into radian as well. But I am converting everything into degrees. So what I am writing? 720 degree. Because 2 beta y will be 4 pi by lambda, and 4 pi is equals to 720 only, right? So from here you can get the value of y. So y is coming out to be lambda by 720, 82.85 minus 360 n. So I can directly check that, I can directly see, I can put n equals to 0 here. If I put n equals to 0, what I am getting? Divided by 720. So 0.11 lambda. So y is equals to 0.11 lambda. 115 it is. So 0.11 lambda I can say. Okay. So this is the location of my first maxima. If I put n equals to 0, so this is my first maxima. The next maxima will be at plus 0.5. So if I do plus 0.5, that would be 0.61 lambda. Then again plus 0.5 I can do. So that would be 1.11 lambda. So these are my maxima location. So what will be your minima? You don't need to calculate. What you can do is that from 0.11 lambda, you need to either subtract 0.25 lambda or add 0.25 lambda. When you subtract, you get to know that this is negative, which is not acceptable. So this you will pick. So 0.36 lambda will be your first minima. So your 0.36 lambda will be your first minima. Then you need to keep on adding 5, 0.5 actually. So 0.86 lambda. Then if I add another 0.5, so 1.36 lambda. So first, what is occurring? Voltage maxima is occurring. And why is that so? Because the nature of your load is inductive plus resistive, but certainly there is inductor. And if there is inductor, that means voltage will lead. And if voltage is leading, so first voltage maxima will occur. Location is 0.11 lambda, that will change with respect to this ZL value. But what did you get to know? That first my voltage maxima is occurring. So that diagram you can make, and here I must have done some calculation mistake. So let me erase it off. So first your voltage maximum will occur. Here what is the value that I don't care, but here what is the value that I care, which is equals to 1 plus under root 5 by 13. So let's calculate it. 5 by 13 under root plus 1, that is 1.62. So this is your 1.62 V naught plus, and minima value is not equals to 0. Minima value is not equals to 0, that is 1 minus under root 5 by 13. So what that would be? 5 by 13 under root minus 1, that would be 0.38. 0.38 V naught plus. So minima value will be equals to 0.38 V naught plus. Okay. So now you are able to differentiate between all the options, I guess. So here what you are getting, 1.62 I naught plus, and minima is 0.38 I naught plus. And what is the location? 0.11 lambda. Then in that manner it will keep on going. This will be 0.36 lambda. Next will be 0.61 lambda. So in that manner you can write it down. Here also first minima will occur 0.11 lambda, then 0.36 lambda, maxima will occur, then 0.61 lambda. In that manner you can write down all the values. And what is your standing wave ratio? Certainly it is not equal to infinity. Current standing wave ratio you can say, or voltage standing wave ratio you can say. This is equals to 1.62 divided by 0.38. So 0.234. So these kind of questions can ask, they can give you a particular load and they will ask you standing wave ratio, they can ask standing wave pattern, they can ask you what will occur first, voltage maxima or minima. So this kind of analysis you can do. It will not take time. If you mug up the formula, then you will just mess it up in the examination, I am pretty sure. But now concepts are clear, load is inductive, so first voltage maxima will occur. And another thing is that here this is not equals to 1, then certainly standing wave ratio will not be equals to infinity. That means certainly V min or I min will not be equals to 0. In case of capacitive load, what will happen? Don't do the calculation. I am not gonna do the calculation, okay? But what I can see is that capacitive load is there. So first voltage minima will occur. I am not sure about the location, okay? But first voltage minima will occur. Voltage minima, or you can say current maxima will occur. And looking at the load, I can tell that my gamma VL, mode of gamma VL is not equals to 1. And if it is not equals to 1, that means my standing wave ratio is not equals to infinity. And if it is not equals to infinity, that what does that mean? that my V minimum is not equals to 0 and I minimum is not equals to 0. So certainly the standing wave pattern will look something, and at y equals to 0 and at y equals to 0 there will be no maxima or minima. In which case you are getting maxima or minima at y equals to 0 when load was purely resistive. When load was purely resistive, at that time only you were getting some maxima or minima at y equals to 0. Why is that so? Because their gamma L was real. And if gamma L is real, that means this term will not come. This term will not come. And if this term is not coming, that means at y equals to 0 only you will have some result. If your gamma is real, if this gamma is real, if this is real, then this term will not come. If this term will not come, then this term will not come. And if this is not coming, then this will be gone. And at y equals to 0 only you will have some results. So that was the reason why you are getting maxima and minima at y equals to 0 only. But if there is some inductor or capacitor, then 100% you will never get maxima or minima at y equals to 0. So these three are the conclusion you can make without even doing any calculation. And believe me, gate examination problem you will be able to solve just by looking at the circuit. You will not have to do the calculation only. They will ask you how the standing wave pattern will look like. This is how it will look like. That first voltage minima will occur or current maxima will occur. Voltage minima or current maxima will occur. You don't need to tell these locations. I am not sure about these locations, but I know that here the gap will be lambda by 4. That's for sure. Here the gap will be lambda by 2. That's for sure. This gap will be lambda by 2. That's for sure. What will be the maximum value? That also I don't know, but I can write it down. This will be I naught plus into 1 plus mode of gamma L. So mode of gamma L you can find out mode of gamma L. And this will be I naught minus 1, I naught plus only 1 minus mode of gamma L. Are you getting this point? Okay. And this will be V naught plus mode of gamma L. So first voltage minima will occur. Why is that so? Because nature is capacitive. So here we are not doing the calculation. We are just writing down the results. Calculation if you wanna do, you can do it. You can find out the location of voltage minima or maxima. That's up to you. But here we are just writing down the results. Okay. So this is what we have understood. So conclusion, you don't need to write down for complex load. For complex load, we are not writing down the conclusion. So complex load, you will keep in mind. What you will keep in mind? That load is complex. So certainly my gamma VL will not be equal to 1. So standing wave ratio will not be equal to infinity. And V minimum, I minimum will not be equal to 0. So certainly if load is not resistive, that means at y equals to 0, you will neither have maxima or minima. Now you need to see whether capacitive nature is there or inductive nature is there. So if capacitive nature is there, that means current maxima will occur first. And if inductive nature is there, that means voltage maxima will occur first. That's it. Now let's see some question. Let's see this question. Comment on the nature of load based on the voltage standing wave pattern. Okay. So at y equals to 0, you are getting something conclusive. Minima or maxima you are getting. That means 100% sure that this has to be resistive, or it could be short circuit, or it could be open circuit. The load could be short circuit, open circuit, or resistive. There are 3 chances. Now if I talk about resistive load, if I talk about some ZL greater than Z0 or ZL less than Z0, if I say this is some resistive load, if it is some resistive load, like just some finite value is there, non-zero value is there, that means ZL is some 25 and Z0 is 50, then what will be my mode of gamma L? That would be ZL minus Z0 upon ZL plus Z0. So that would be coming out to be 1 by 3. Something like that would come out. And that means standing wave ratio will not be equal to infinity. But here it is equal to infinity. So one thing I am pretty sure that load is either short circuit or open circuit. It cannot be resistive as well. Because if it was resistive, if it was a non-zero resistance value or finite non-zero resistance value, then certainly my standing wave ratio would not be equal to infinity, But here it is infinity. Now you need to think whether it is short circuit or open circuit. So what is occurring first? What is occurring first? Voltage minima is occurring first. That means your gamma VL would be negative. And what it will be equal to? It will be equal to 1 only. So from here I can tell that my gamma VL will be equal to minus 1. Why is that so? Why minus sign? Because voltage minima is occurring first. And now why 1? Because standing wave ratio is infinity, no? If standing wave ratio is infinity, then certainly your gamma has to be 1 only. How this negative sign came? Because voltage maxima is occurring first. Now gamma VL is equals to -1 when this occurs, when ZL is equals to 0, because what is the formula? ZL minus Z0 upon ZL plus Z0. So if ZL is equals to 0, then gamma VL will be equals to -1. There you go. So which kind of load is that? Short circuit. So if your concepts are clear, if your diagrams are clear, then certainly you will be able to write down these answers. Okay. Now let's see this one. At lambda by 4 you are having minima, voltage minima. That means at lambda equals to 0 you are having voltage maxima. At lambda by 4 you are having minima. So this is lambda equals to 0, you are having maxima. At load only you are getting something conclusive. So what are the options? Short circuit, open circuit or resistive. Right? If it was short circuit or open circuit, then gamma VL would have been equals to 1 and the standing wave ratio would have been equals to infinity. But here standing wave ratio is finite. Here your standing wave ratio is finite. So first thing I see that standing wave ratio is finite. So short circuit, open circuit cannot be there. Now the load has to be resistive. Why resistive? Because at y equals to 0 only you are getting something conclusive. If you are getting something conclusive, then load has to be resistive. Now which resistive? ZL greater than Z0 or ZL less than Z0? ZL greater than Z0 or ZL less than Z0? At y equals to 0 you are having voltage maxima. Voltage maxima, that means certainly your gamma VL is equals to positive. Why it is positive? Because you are having voltage maxima here. If you are having voltage maxima, that means ZL is greater than Z0. ZL is greater than Z0 and this ZL is resistive load. Now at y equals to 0 you are not getting anything conclusive. So that means it could be either resistive load, it could be either inductive load, capacitive load or complex load. And in complex as well there are two chances, resistor plus capacitor and resistor plus inductor. Now what kind of load it would be? So first thing what you will see, it cannot be inductive or capacitive. It cannot be purely inductive or capacitive. Why is that so? Because here you can see S is equals to finite. But if it was purely inductive or capacitive, then magnitude will be mod of 1. So here you can see that my mod of gamma V is not equals to 1. So certainly it cannot be inductive or capacitive. So it is complex load. Certainly it is complex load. But in complex load, what kind of load is that? Resistor plus capacitor or resistor plus inductor? So what do you see? First, what is occurring? Voltage minima is occurring. And voltage minima occur in case of capacitor. So here load is ZL is resistive plus capacitive, or you can say complex load. Say yes or no. What kind of load is that? It is a complex load, resistive plus capacitive. Why? How did you conclude that? First you saw that standing wave ratio is not equals to infinity, that is finite. So it cannot be inductive or capacitive. It cannot be resistive because at y equals to 0 you are not getting anything conclusive. Then you got to know that first voltage minima is occurring. So that has to be capacitive in nature. So resistor plus capacitor. There you go. This is the answer. Okay. So a very typical type of concept we have seen in a very easy manner. I hope you enjoyed the discussion. Now we just need to solve problems. Some easy problems only we will solve because most of the problems we have solved through concept only, right? So let's take a break. It's been 46 minutes. So I will take a break. You can also take a break and start solving these problems. I can show you the questions. This is the first one. Very easy. The second, third, fourth, and this is fifth. That's it. So these 5 questions you need to solve. Okay. You can try doing it on your own. I will pause the video and then I will start solving it for you. Okay. Yeah, so let's start the question. So you need to find the voltage reflection coefficient, or what they are saying, voltage reflection coefficient at the input of this transmission line, So what you are going to do, first you need to replace these transmission line by their equivalent resistance, equivalent input resistance. This is A, this is B. So between AB there is this transmission line also connected, and between AB there is this transmission line also connected. So both of the input impedance we need to write. Since length is lambda by 4, so can I write down the input impedance? Yes. One would be Z0 square by ZL. Z0 square by ZL 100 I am taking. So this I am talking about. So 50 into 50 divided by 100. 50 into 50 divided by 100. So that would be 25 ohm. Similarly for this AB as well, another Z in 2 I can take. Z0 square by ZL, that is 200. So 50 into 50 divided by 200. So what that would be? 50 by 4, that would be 12.5 ohm. Okay, so what will be the total impedance between A and B? AB, that here it would be 50 into 50 divided by 125, and this is 12.5. So 25 parallel with it 12.5. So 25 into 12.5 divided by 37.5, 25 by 3. So this is your 25 by 3. So this equivalent will be 25 by 3. And then there is a transmission line. Transmission line of length lambda by 4. This length is lambda by 4. And here you need to find gamma. So what is the formula? The formula is ZL minus Z0 upon ZL plus Z0. But that is at load. Now you need to cover lambda by 4 distance from the load. So what that would be? E to the power j beta L. What is beta? E to the power minus gamma L. The formula, The formula is e to the power minus 2 gamma y. But you need to cover distance L, and L is equals to lambda by 4. So you need to cover the distance lambda by 4. But one thing is that this is a lossless transmission line, so it would be j beta. So e to the power minus 2j beta, in place of y I will write down L. Are you getting this point? This formula we have already studied, ZL minus Z0 upon ZL plus Z0, but you need to find at the input side. Input side means distance L from the load. And what is the distance L? That is lambda by 4. L here is equals to lambda by 4. Distance L from the load. ZL minus Z0 e to the power minus 2j gamma y. E to the power minus 2 gamma y, and gamma is equals to j beta. So this is what we have written. What is your beta L? Beta L will be 2 pi by lambda into lambda by 4. That means pi by 2. So beta L is pi by 2. And what is ZL? ZL is 25 by 3. So 25 by 3 minus Z0, 50 divided by 25 by 3 plus 50. So what you are getting? Minus 125 divided by 175. And wait a second. Here I forgot to write e to the power minus, this is your beta L, this is your beta L, but here it is 2j beta L. What is beta L? Pi by 2. So this is becoming 2 and 2 will get cancelled, e to the power minus j pi. E to the power minus j pi. And what is the value of e to the power minus j pi? Minus 1. Right? The value of e to the power minus j pi is minus 1. How it is minus 1? E to the power j theta is equals to cos theta plus iota sin theta. So if you put minus pi, then cos minus pi is equals to minus 1 and sin pi is equals to 0. So minus 1 only. So if you solve this one, what you are getting? This will be your minus 125 divided by this will be your 175 into minus 1. So from here 5 by 7 you are getting. So answer is your gamma at distance L is 5 by 7. So this was an easy question only. If you have seen the concept already, this was an easy question. So answer is 5 by 7. This is the answer. What did we do? Initially we calculated the impedance 25 by 3. At load, what will be the gamma? ZL minus Z0 upon ZL plus Z0. So if you do 25 by 3 minus 50, so 37.5 it would be, and 12.5, that would be 62.5. Yeah, so that would be 5 by 7 only. 5 by 7. Yeah, so here you are getting minus 5 by 7, but you need to calculate the gamma value at a distance L from the load. And what is L? L is lambda by 4, because you need to find it at the input. So e to the power minus 2j beta L, e to the power minus 4 pi by lambda into L. What is the value of L? L is lambda by 4. So e to the power minus j, what is that? 4 by lambda into lambda by 4. So that would become e to the power minus j pi, and that value is equals to minus 1. So from here you are getting 5 by 7. Is that clear to you? Okay, fine. Very easy question. What this question is saying? You need to find the deflection coefficient. So what do I know? 1 plus gamma upon 1 minus gamma. Mode of 1 plus mode of gamma divided by 1 minus mode of gamma. So what is this given? 3. So from here you can solve and get the value of mode of gamma. But Along with that, what you can do is that you can develop another formula. What I am saying is that if you get gamma at left hand side, then in terms of S you can get the value of mode of gamma. So this is what you will be getting. Are you getting this one? What I am doing is that S equals to 1 plus, I am calling X, mode of gamma I am calling as X. So 1 plus X upon 1 minus X. Then S minus Sx is equals to 1 plus X. What I need to do, I need to show X in terms of S. So what I will be doing is that, so this X, this Sx I can take this side. So S minus 1 is equals to X plus Sx. So what you are getting, X is equals to S minus 1 upon S plus 1. So what is X? Mode of gamma. So mode of gamma is equals to S minus 1 upon S plus 1. So this also you will remember. Okay, so in that manner you can calculate. So this is equals to S plus 1 upon S minus 1. So mode of gamma directly I can calculate 3 minus 1 upon 3 plus 1. Okay, so 2 by 4, 1 by 2. So this was just to tell you that there is another formula. What is that formula? S minus 1 upon S plus 1 for mode of gamma. About the sign, you need to have another information, that voltage maxima is occurring first or voltage minima is occurring first. Then you can calculate the sign of gamma as well. But for the magnitude only, S minus 1 upon S plus 1. You can put mode of gamma equals to 1 by 2 here as well. You will get the same thing. If you put 1 by 2 here, 3 by 2 divided by 1 by 2, what you are getting? 3 only. Okay. So just I picked this question just to tell you that there is another formula, S minus 1 upon S plus 1. For a 2-wire transmission line, adjacent voltage maxima are at this distance operating frequency. That means what is the gap between two adjacent voltage maxima? What is the gap? That is 27.5 minus 12.5, and that would be equals to lambda by 2. So lambda is equals to 30 centimeter. What you need to find? Operating frequency. And in air, that means my speed of light, speed will be equal to the speed of light. So what do I know? Vp, what do I know? Lambda is equals to C by F. Actually it is Vp by F. Vp by F. But Vp is equals to C. So F is equals to Vp by lambda. So what is Vp? 3 into 10 to the power 8. And what is lambda? 3 into 10 to the power minus 1. So F you are getting as 10 to the power 9, or you can say 1 gigahertz. So your operating frequency is 1 gigahertz. Very simple question, very straightforward. Now this question, voltage standing wave pattern in lossless transmission line with characteristic impedance 50 ohm has been shown, and resistive load is there. This should not be mentioned, like they cannot mention resistive load, and the load is there directly. But can you tell whether it will be resistive load or it will be short circuit or it will be inductive? What you can see? You can see it is resistive load only. Why is that so? Because at y equals to 0 only you are getting something conclusive, and your standing wave ratio is not equals to infinity here. Okay, and at y equals to 0 you are getting something conclusive. What is that? There is voltage minima. Here there is voltage minima. So at y equals to 0 you are having voltage minima. Standing wave ratio is not equals to infinity. Standing wave ratio is equals to 4. So certainly it has to be resistive load. But what kind of load would be there? ZL greater than Z0 or ZL less than Z0? Since voltage minima is there, that means ZL is less than Z0. Because if voltage minima is there, that means my mode of gamma L would have been negative. So ZL less than Z0. Okay. And if ZL is less than Z0, what do you mean? S is equals to, if you remember or forget about this, if you remember the formula of ZL, what did we write? In the initial part, in the very initial part of this video, one formula of S we wrote in the conclusion. Or one formula of ZL we wrote, S Z0 or Z0 by S. So two kind of formula are there, S Z0 or Z0 by S. So that formula we are going to apply here. Formula of ZL is equals to S Z0 or Z0 by S. Which one will you pick? Here ZL is less than Z0. That means this one you have to pick and this you will eradicate. So ZL is equals to Z0 by S. So what is the value of Z0? Z0 is 50 and divided by 4. So what you are getting? 12.5. So both of the options will be mentioned. 50 into 4, that means 200 ohm will also be mentioned. But you need to check that ZL cannot be greater than Z0. Why it cannot be greater than? Because at y equals to 0 you are having minima. If you are having minima, that means ZL has to be less than Z0. So which is the possible option? There you go. Okay. Or there could be other method. What could be the other method? That standing wave ratio is given, that is 4. So from here I can get mode of gamma L. This is your method 2 I am saying. What I can get? Mode of gamma L. What that would be? S minus 1 upon S plus 1. So that would be 4 minus 1 upon 4 plus 1, 3 by 5, or you can say 0.6. So mode of gamma L is equals to 0.6. But this is the magnitude. I need the sign as well. How I will get the sign? I will get to know that at y equals to 0, there is voltage minima. That means gamma L has to be negative. Why is that so? Because at y equals to 0, there is voltage minima. So if that has to be negative, that means your gamma L is coming out to be minus 0.6. Now from here you can apply the formula ZL minus Z0 upon ZL plus Z0, that is equals to minus 0.6. Now Z0 value is given as 50. So from here also you can get the value of ZL. ZL plus 50 is equals to minus 0.6. So if you solve it up, ZL minus 50 is equals to minus 0.6 ZL plus minus 30. So 1.6 ZL is equals to 80. ZL is equals to 80 by 1.6. Some calculation error is there, and 20 by 1.6. Yeah, that's what I was thinking. 20 by 1.6. What you are getting? 12.5 only, right? Because 20 and this can be written as 16 10 200 by 16. So yeah, 12.5 only. You can do this with the help of calculator as well. So from here as well, if you do the calculation, you are getting ZL equals to 12.5 ohm. But this will take a bit of more time, right? So 12.5 ohm, and here you are getting reflection coefficient is minus 0.6. But this will take a bit more time. But if you are smart enough, you would get to know that load is resistive. So I can apply this formula as Z0 or Z0 by S. How will I pick which formula I need to apply? By looking at the standing wave pattern. Initially voltage minima is there. If voltage minima is there, then certainly the load has to be lesser than Z0. ZL has to be lesser than Z0. And if ZL is less than Z0, then what does that mean? If ZL is less than Z0, then certainly you need to apply Z0 by S. Is that clear to you? Very easy question. This was asked in gate only. All these questions are gate question only. This was also gate question as far as I remember. This was certainly gate. These are gate examination question only. You try doing it on your own. It is very easy. Just you know everything, every single thing you know. Just have the patience, you will be able to solve. This transmission line is given, then there is a load, then another transmission line is given, then open circuit load is there. They have given this gamma reflection coefficient at the input side, and they have given the magnitude of that. What will be the magnitude of this gamma? That would be equals to, what will be magnitude of this gamma? That would be equals to ZL minus Z0 upon ZL plus Z0. If I talk about the magnitude. But now they are saying that this is depending on frequency. This reflection coefficient is depending on frequency. At 0 frequency and at 1 gigahertz, at 2 gigahertz and 3 gigahertz, it will be 0. Reflection coefficient is 0. So if mode of gamma L is 0, what I am saying, I will pick something. I am not picking 0 gigahertz, I am picking 1 gigahertz. Okay, at 1 gigahertz, what I can see is that mode of gamma is equals to 0. What does that mean? That ZL is equals to Z0. That means this load, which load is ZL? I am calling this load as ZL. This load as ZL. So this load ZL is equals to Z0. This ZL is equals to Z0. But now in this load, along with 50 ohm, there is another impedance. Only 50 ohm impedance is not there. There is another impedance, which is this one. So how do you think this gamma is depending on frequency? This gamma is depending on the frequency because this Z in input impedance, will depend on this length. Not only length, it will depend on J Z0 tan beta L. So it will depend on beta, and beta will depend on frequency, because what is beta? 2 pi by lambda, and what is lambda? Lambda is C by F. So beta is depending on frequency. So that's why this is depending on frequency. But any one frequency I am picking, that at 1 gigahertz ZL is equals to 50 ohm. That means if you look from here, at 1 gigahertz, if you are looking from here, you are getting 50 ohm. What does that mean? 50 ohm is already there. That means from this transmission line, you need infinite impedance. So at 1 gigahertz, Zin should be equals to infinity. If I write down at 1 gigahertz, at f equals to 1 gigahertz, Zin is equals to infinity. Because if Zin is infinity, then what will happen? ZL will be equals to 50 parallel with infinity, 50 ohm. So ZL will be equals to 50 ohm. And if Zn is infinity, that means at 1 gigahertz, Zin has to be infinity. Now when it can be infinity? This is your load impedance. Load is also infinity. Here this load is also infinity, no? If I call it ZL dash, that is also infinity. Now infinity should be coming at the input as infinity only. That means whatever that is there at ZL dash, the same should be there at Zin. That means ZL dash should be equals to Zin. When it can happen? When your length is the multiple of lambda by 2. So just you need to think like that in the examination. That sir, at 1 gigahertz I can see that my reflection coefficient, mode of reflection coefficient is equals to 0. That means ZL has to be equals to Z naught. That means this much load should be equals to Z naught. Now in this much load, what all things are coming? 50 ohm parallel with this impedance. Now if I need this complete impedance equals to 50 ohm only, that means from here I need infinity impedance. And from here if I need infinity impedance, that means my load is already infinity, I need to replicate infinity here only. And if I need to replicate infinity only, then what should be my length? Length should be the multiple of lambda by 2. There you go. From here, what did you get to know is that at frequency equals to 1 gigahertz, my length should be multiple of lambda by 2. Now, what value of n you will pick? Look, if you pick n equals to 0, that means you are talking about 0 gigahertz. Then n equals to 1, that means you are talking about 1 gigahertz. Then n equals to 2. Basically, here the length should be multiple of lambda by 2. It could be 0. Basically, it could be length could be 0. Or it could be lambda by 2, or it could be lambda, or it could be 3 lambda by 2. If I put length is equals to 0, that means this transmission line is not even there. If I say length is 0, that means transmission line is not even there, then directly open circuit would be coming here. So that I cannot do. I cannot write down that length is equals to 0. Length is there, finite length is there. Now next what I can think, length is equals to lambda by 2. So what is the next time? What is the next time when reflection coefficient is 0? That is 1 gigahertz. That means at lambda by 2, when your length is lambda by 2, if you consider your length to be equals to lambda by 2, that means at that time, what frequency you need to pick? 1 gigahertz. With respect to, look, this length is lambda by 2. But if frequency is changing, that means lambda value is changing, because what is lambda? Lambda is equals to C by F. So if frequency is changing, that means lambda value is changing. And if lambda value is changing, then it's not necessary that length will be always lambda by 2. It could be lambda by 4. With respect to some different frequency, it could be lambda by 4. You are not getting what I am saying. Let me give example. First, let me solve it, then it will be more easy for you. What I mean to say is that I got to know that I need to replicate ZL equals to infinity. So I am saying that I will put n equals to 1 here. So my length should be equals to lambda by 2. But it should be at 1 gigahertz. So lambda is equals to C by F. C by 2F. And what is C? Not C, sorry. Vp by F. Lambda is equals to Vp by F. What is Vp? 2 into 10 to the power 8. 2 into 10 to the power 8. Divided by 2. And what is the frequency that I am saying? 1 gigahertz. That means 10 to the power 10 to the power 9. So length what you are getting? 0.1 meter. Now other people will have a doubt that sir, why did you pick n equals to 1? Why you did not put n equals to 2 or 3? So let's take more example. Let's take the condition here. So this is the answer, but I am explaining it more. What I am saying is that at f equals to 0.5 megahertz, at f equals to 0.5 megahertz, what is the value of gamma? What is the mode of gamma? That is equals to 1. This is what they are saying. Mode of gamma is equals to 1. Right? What does that mean? If mode of gamma is equals to 1, then ZL can be either open circuited or short circuited. ZL can be either open circuited or short circuited. Because what is gamma? Gamma L is ZL minus Z naught upon ZL plus Z naught. So if ZL is 0, then mode of gamma L will be minus 1. If ZL is 0, then gamma L will be minus 1, then mode of gamma L will be 1. And if ZL is infinity, then gamma L will be 1 or mode of gamma L will be 1. Right? So in both of the cases, when ZL is equals to 0 and ZL is equals to infinity, in both of the cases, gamma L will be gamma L, mode of gamma L will be equals to 1. Here also mode of gamma L will be equals to 1. So here which condition you will pick? ZL equals to open circuit or short circuit? Basically from here you would want to see open circuit impedance or short circuit impedance. So can you make ZL equals to infinity ever? Can you make ZL equals to infinity ever? There is 50 ohm and in parallel some resistance will come. Okay, 50 ohm in parallel some resistance. You connect any kind of impedance, you can never make this much impedance equals to infinity. Here 50 ohm and in parallel there will be some impedance. So no matter whatever that you connect here, your impedance can never be infinity. If you connect open circuit, then impedance will be 50 ohm. If you connect short circuit, then impedance will be 0 ohm. So you can never make your impedance go to infinity. That's for sure. You can never make your ZL go to infinity. So that means your ZL has to be open circuit only. So from here, which conclusion I made? From here, the conclusion that I made that this open circuit is not possible, because if I say open circuit, that means I need to make this much impedance infinity, and if I am making this much impedance equals to infinity, what does that mean? Which is not even possible. So what it has to be there? That ZL has to be shorted. So ZL has to be shorted. So from here, which conclusion you are making? The ZL has to be short circuit. And what is ZL? ZL is this 50 ohm, and then there is another impedance, that is Zin, which I have called as Zin only, no? Yeah. So 50 ohm, this is 50 and this is Zin. This is your ZL. This is your ZL. And you want your ZL to be 0. If you want your ZL to be 0, that means Zin has to be 0. Now if Zin has to be 0, your load is open circuited. Your load is open circuited. And you want your Zin to be 0. What does that mean? Open circuit to short circuit. You want conversion from open to short. And if the length is lambda by 4, then only there can be this conversion possible. Are you getting this point? If your length is equals to lambda by 4, then open will be converted to short and short will be converted to open. So since this is open and I need to convert it to short, so that means length has to be equals to lambda by 4. So here your answer is coming that length has to be equals to lambda by 4. But this lambda by 4 is with respect to 0.5 gigahertz. Right? So what I am going to write? What is lambda? Lambda is Vp by 4f. What is your Vp? Vp is 2 into 10 to the power 8 4f. F is 0.5 giga. So what you are getting? Giga is 10 to the power 9 only. So what you are getting? 0.1. So again your answer is 0.1 meter. Here also your answer was 0.1 meter. So you cannot say that, sir, my length will be lambda by 2. Nah. Your length will be lambda by 2, but with respect to 1 gigahertz frequency. My length will be lambda by 4, but with respect to 0.5 gigahertz frequency. My length will be lambda. What I can say? My length will be lambda. My length will be lambda, but with respect to 2 gigahertz frequency. Why 2 gigahertz frequency? My length will be equals to lambda, but with respect to 2 gigahertz frequency, because at 2 gigahertz, again your gamma L is becoming 0. That means again your ZL is equals to Z naught. That means again this length has to be multiple of lambda by 2. So again it has to be multiple of lambda by 2. So the length has to be lambda this time. Next time you can pick length equals to 3 lambda by 2. So if you put length equals to lambda, but the frequency what you need to put? 2 gigahertz. Again you will get the same answer. So this question was very intelligently framed. Are you getting this point? Like everyone says that the length has to be equals to lambda by 2, and they tell that you put f equals to 1 gigahertz and then you get this answer. That is answer matching. But the concept is different length can be there. You can study this complete diagram. At 0.5 as well you can analyze at 1 gigahertz, you can analyze at 1.5 gigahertz as well, you can analyze at 2 gigahertz. Why I started from 1 gigahertz? Because that seemed easy for me. That my reflection coefficient is 0, that means ZL has to be equal to Z naught. I can see directly it is 50. So here I need open circuit only, and if I need open circuit, that means length has to be the multiple of lambda by 2. So length equals to lambda by 2 I can pick, and if I pick length equals to lambda by 2, what does that mean? That my frequency I need to pick as 1 gigahertz, because at 1 gigahertz I am getting reflection coefficient equals to 0. But I can analyze at 0.5 gigahertz as well. And how would I analyze that? Did you understand that point? Yes. How would I analyze? I would just see that at 0.5 gigahertz I would need my load to be either short circuit or open circuit. but I cannot make it open circuit. Why I cannot make it open circuit? Because 50 ohm is already there. So there is no chance I can make it open circuit. So I have to make it short circuit only. That means my length has to be lambda by 4, not lambda by 2. But lambda by 4 with respect to frequency equals to 0.5 gigahertz. So I hope this point is clear to you. And I hope this discussion was very fruitful. This is the end of the lecture and we have seen a lot of concept and you will be able to solve, believe me, you will be able to solve any problem related to reflection coefficient or standing wave pattern, and you can ask your friends what kind of typical concept it is. But we have understood in a very good manner. We spent roughly around 5 hours. 5 hours. How 5 hours? 2.5 hours here and 2.5 hours here. So after the 5 hours of complete dedication, we are able to understand standing wave pattern and everything related to reflection coefficient in a very good manner. Okay then, thank you very much. Let's meet in the next lecture. In the next lecture, we will see the time domain analysis of transmission line. We will see the transient and steady state. So that is also very interesting topic and very conceptual as well. And there also there are some misconceptions that we will clear. Okay, thank you very much.